Good morning. Can you hear me? Hello? Just want to make sure that the audio and video are okay. Can everybody just say something or give a thumb up or type in the chat or whatever. Just make sure that is good. Okay. Let me change the audio real quick and then we start class. Testing. All right. Then we're good. Once again, welcome to class. I'm glad you're here. I hope everybody is okay. Right. We start section 1.5. That's where we start. Quadratic equation. Quadratic equation is the quadratic in this form: x squared plus bx plus c equal to 0. What makes it quadratic is the x squared. So that's why we need the coefficient not equal to 0. Right. But before that, let's look at the complex number. Complex number, we define it. Before we define complex number, we have imaginary unit, and that is square root of -1. By the way, I left my note in my office, so I don't know where do we start last time. I think we go a little bit over this, but that's fine. I think we stop at this problem, but regardless, just want to start from the beginning of the section. Anyway, so imaginary unit defined to be I, and I is square root of -1, and or we can say I square is -1. So I is square root of -1. And a complex number is a number that might have I in it or maybe not. But in general, this number are complex number. 2 plus 3i So it has a real part and imaginary part would be negative. Or maybe just purely imaginary. Just imaginary, just have I in it. Or maybe just real numbers. So all of these are complex numbers. And if we have a plus bi is the form of a complex number, so is a minus bi and a plus bi, both of them are complex number, and they conjugate of each other. And when we multiply, we just multiply them out. A plus bi times a minus bi, we have a squared. Multiplied out. A squared minus b abi plus abi plus minus bi squared. I squared here is -1, and that's why we have -1 here. And negative turn to a plus. We'll get back to this in chapter 3. Actually, what do we do with the square root of a negative number? Square root of a negative number. Whatever we do, if we have a negative inside a square root, where b is positive, we'll take that negative outside, and it becomes an I on the outside of the square root. So, you see how that works. Square root of -4, I just copy the problem. See, there's a negative inside the square root. First thing we do is turn into an I outside of the square root. So the negative, take it outside of the square root, and we just have that. Square root of 4 is 2. So we have I times 2, or we have 2i. Okay. By the way, I hope the video and audio are okay. Can just give a thumb up, or on the top there's the react. Just click on the thumb up or smiley face or anything. I just make sure everything's good. Anyway, we continue. Square root of -12. So we once again has a negative. We have a negative inside square root. That is the imaginary I. And we have 12. Okay, so there's nothing wrong with that. Now, so we have 12. What can we do? I just want to go back to the previous problem where we have square root of 4 is equal to 2. So let's write that down. Square of 4 is equal to 2. Well, because 2 square is 4. Another way to write this is square root of 4 is 2 times 2. And that is equal to 2. So in general, if we have two numbers inside the square root, that number will come out. So let's look at another example. Let's see. There's 20. And we'll divide by the prime number. Let's say if we have list of the prime numbers are the numbers divided by 1 in itself. 2, 3, 5, 7, 11, and so on. So prime, this why write little note, prime number divided by 1 and itself. Okay. So 4 cannot be prime because 4 divided by 2, not 1 in itself. 6 divided by 2 and 3 is not prime. 9 divided by 3, 8 divided by 2 and 4, so then not prime. So those are the prime number, and we break any number into the product of prime number. So we start that list. There's a 2, and then there are 10. 20 is 2 times 10. 10 is 2 times 5. And now we have all the prime number. So we say 20 is 2 times 2 times 5. Now we have the square root of that. So for every pair, one number come out. And we left with 5 inside square root. So the answer is 2 square root of 5. So that's how we simplify it. So now we have 12. We do the same thing. 12, the first prime number divided by is 2. 12 divided by 2 is 6. 6 is 2 times 3. So we write I square root 12 is going to be 2 times 2 times 3. And now we have a pair of 2. So I times a pair of 2. That 2 come out of the square root. And now we have square root of 3 inside. And so I times 2 times square of 3. Usually I will write I after the 2. So like alphabetical order, the number go first, and then letter, and then anything else, like square of 3. Okay, so that's how we simplify. So we need that for the later part of the section. But now we get back to quadratic equation. Quadratic equation, what we're trying to solve for is the equation that has the x squared. The x squared will make it quadratic. So that's why we want the a not equal to 0. Is if a equal to 0, we don't have quadratic. We don't have the x squared, and that cannot be quadratic. So the highest degree has to be x squared, and that has to be there. Right. So in this section, there are 3 different ways to solve for quadratic equation. The first one is by factoring, complete square, and quadratic formula. So by factoring, meaning using the zero product principle. Zero product principle. So what is zero product principle? Zero product principle says if a product is 0, then one of the factor equal to 0. Now it only works for 0. If we say a times b is equal to 8, that will not work because that's not 0. Besides, if we have this, a could be 2, a and b could be 2 times 4, 1 times 8, -1 times -8. There are a lot of possibilities. But if we have a product equal to 0, if it equal to 0, then it has to be, one of them has to be 0. So a is 0 or b is 0. So only works if we have 0. Right. So that is zero product principle. Now Now, how do we factor? Now to factor ax squared plus bx plus c, we use factor by grouping. We need to split this into two terms, b1x and b2x. Our middle term we split into two. And why do we do that? I'll say in a minute. And after that, a product, we will find two numbers. The product equal the first time the last, and the sum is equal to middle number. So once again, the product equal the first time the last, the sum add up to the middle number. Alright, so keep that in mind. Let's see how that works. Look at one example. Now factor 6x squared minus 5x minus 6. So first step is find two numbers. Such that a product, meaning they multiply together, equal to first times the last. The first number times the last number. Okay. And now they add to the middle number, which is -5. So let's denote, we need the product, two things times together, equal to first times the last. And two things add up together equal to the middle number. Right now we just find. So the product of -36 to get to -36, what can we do? So it could be 1 times 36, but one of them has to be negative. So let's say -1 and 36, or 1 times 36, but they do not add up to -5. So have to go to something else. -2 and 18. Nope. 2 times -18. They don't add up to -5 either. Okay, keep going. 3 and 12. -3 or -12. Don't add up to -5. And then 4 and 9. How about -4? No, still no. But 4 and -9. Yes. This number add up to -5. So yeah, should have found two numbers. 4 and -9. So that's the first step. Next, we split the middle term. So now the problem will become 6x squared, and then we have 4 and -9. Plus 4 and -9. So we split the middle term. Instead of -5x, it becomes 4x minus 9x, and then -6. So split the middle term. Let me write real quick. 6x squared minus 5x minus 6. The negative 5 split into 2. Right. And after that, we factor group the first two and the last two. Factor by grouping. Meaning the first two terms and last two terms. So let me write. Okay. 6x squared plus 4x minus 9x minus 6. Okay. Now we group first two and the last two. Okay, so what do they have in common? And we can factor out. So in that case, let's take a look at the first two. 6x squared plus 4x plus 2x. You can say that both of them have an x, so that is the common, so which is good. Or we can do this. We're just doing the slow motion here. So now the 6x squared. Now just focus on that. 6x squared. I can write 6 is a 2 times a 3. X squared is an x times an x. Okay. And then the 4x you can write as 2 times 2 times x. And you cannot break down any further. Remember the prime factoring earlier we break that down all to prime numbers. And even the x is x squared x times x. We break down like product like this. And now we look at what do they have in common. Okay, we see that there's an x on both of them. There's a 2 on both of them. So in that case, we say there's a 2 and an x that are common. And now we write the common factor out, 2x. After we write the common factor out, we left with the different, the 3x plus 2. That's how we factor. This we have 2x is common. And then we have 3x plus 2. Okay, so that's the first two. Now, the last two, negative 9x, negative 6. So we break down. Negative 9 is 3 times 3 times x. The 6 is 2 times 3. So here what we see they have common is there's a negative. Both of them has a negative. And both of them have 3. Negative and 3. I will write that as a common factor. And what's left that are not common is 3 times x. And there's no more sign. We took the negative common out, and there's 2. Positive 2. Okay, so that's what we have. The common is negative 3. And we have 3x plus 2. Now, we see that if everything done correctly, we should have a common factor, 3x plus 2. And then you write that common factor out. Now you're left with 2x minus 3. That's it. That's how we factor 6x squared minus 5x minus 6. Okay, so that's good. Let's go factor by grouping. Another way factor is called the box method. This is also number 3. Alternatively, use box method. to factor. So instead of doing this, I can use the box method. The box method will be this. We draw a box 2 by 2. The first term, 6x squared, I'm going to put here. And the last term, I'm going to put in that corner. And the other two corners, I have 4x and -9. You can put either way, here or here. Okay. And after that, we'll write the common terms. The common term of 6x squared and 4x, we do the same thing. We see the common is 2x. Just going to put 2x is common here. And now the common of -9x and -6, we set that is -3. Again, the sign will go with the left and the top. So -9. Sorry. The common of this is -3. Yeah, we just write the common term. -3. Okay. And now those two terms, 6x squared and -9x. Okay, 6x squared, -9x. 6x squared is 2 times 3 times x times x. 9x is 3 times 3 times x with the negative. Alright. Look like they will have a 3x in common on both of them. One positive, one negative. We're not going to choose the negative sign. We only choose the sign that go with the one on the left and the one on the top. We'll see that later. But now they have the 3x in common from those two. The sign of course go with the top. So 6x squared positive. So that's why I choose positive 3x. And finally for x and -6, we do that again. Look like both of them divide by 2. And the size here is, the top is positive. So it's going to be positive 2. And finally we have 3x plus 2 and 2x minus 3. Okay, so that's how we factor. And from factoring, the next step to solve for solve for equation, it should be simple. The last step is simple. Now look at the equation. Solve equation by factoring. Equation by factoring, meaning we're going to use the zero product principle. Meaning we have to have 0. That means we need 0 to be on one side of the equation. So we need 0 on one side of the equation. Because if it's not 0, we cannot use that principle. So we don't have 0 here. The first thing I'll do is, if I subtract 4 on both sides, I will have that 0. Okay. Now, factor. The 3 steps of factoring. The first one, of course, find two numbers. Something times something equal to the first times the last. The first number is 2. The last number is -4. So that is -8. And those two numbers have to add up to the middle number of 7. need to get to negative. So take negative 8. What is equal to negative 8? 1 times 8, 2 times 4. Okay, those are. So 1 times 8. But this needs to be negative. So let's say 1 times negative 8 or negative 1 times 8. And we see that these two, negative 1 times 8, add up to 7. So we have negative 1 and 8. Those are the two numbers. That means we'll split 7x as negative 1. Now we split. To x squared plus 7x minus 4. We split 7x into negative 1x plus 8x. Negative 1 and 8. The first term is still the same thing. Okay, and now the next is by grouping. I'll use the box method. I'll use box method. Okay, so a box. To x squared minus 4, and then we have negative 1x plus ax. Okay, now what they have in common, look like there is just an x there. These two, there's a 4. We do like what we do in here. Just spell out the product. A is 2 times 2 times 2, and 4 is 2 times 2. So there are 2 times 2 in common, which is 4. Again, the sign will go with the one on the left and the one on the top. It is positive 8 on the left, so it's positive. Okay, and now the top, both of them have an x, both of them have a 2, and now negative. So this is just a negative in common, negative 1. So we have x plus 4 and negative 2x minus 1. Mean 2x minus 1. Okay, so that's the factor. And then finally, this one we have to solve the equation. So last step is we solve, and from here we can write as x plus 4 and 2x minus 1 equal to 0. And now 0 product principle. A product is 0. That means each of them, at least one of them is 0. So either this one is 0 or that one is 0. We just solve for x, and we have x equal to negative 4. Okay, and then the other side, to x equal to 1 and divide by 2 on both sides. We have x equal to 1/2, and we can write the solution as a set. So we just have a curly bracket, and we write the solution inside it. We have a negative 4 and 1/2. So that's how we write the solution. Okay. So let's look at another example. Now we solve this equation. Okay. So of course we do the same thing, factor by zero product principle. We already have 0, so this problem is good. We don't have to worry about subtract the 4 on both sides like this. So that's good. However, very important when we solve by factor is that if this is a problem, we can simplify whenever possible. So that's very important. Especially the box method will not work if you don't factor out the first number. So note that for box method to work, we need to simplify the problem to the simplest term. It will not work otherwise. Simplify the terms to the smallest coefficient. When possible. So this particular problem is possible. All of them are even. So why don't we divide everything by 2? So the problem we reduce to are much smaller terms. 2 divided by 2 is 1. So just have x squared. Negative 14 divided by 2, 7. And 20 divided by 2 is 10. So we have that. Now the step of factoring and solve for that should be like what we've seen before. So first, find the two numbers. Multiply together equal the first, which is 1 times the last 10. And they have to add up to the middle number of negative 7. So try and error. To get to 10, 1 times 10, negative 1 times negative 10, none of them add up to negative 7. So that means we have to keep going. 2 times 5, 7. But negative 2 times negative 5. Those are the two numbers. Negative 2 and negative 5. Add up to negative 7. So the two numbers are negative 2 and negative 5. Okay. Second step is we split the negative 7x will be split into the middle term will be split into 2 that has negative 2 and negative 5. So from here to here. On the test, you can just go directly to this. You might not need to show the step in the middle. Number 3. Factor. I use the box method here. x squared plus 10 negative 2x negative 5x. Yeah, we split into two terms. Now, these two, the common is going to be x. The common here is going to be 2. But once again, I choose this number, choose the sign, go with the one on the left or on the top. So this is negative. X squared and negative 2x. The x is common. And 5 and 10, that is the 5. But I choose the sign with the one on top or the one on the left. So if x minus 5 and x minus 2. And the last step is to solve for it. And we have x minus 2 and x minus 5 equal to 0. So the zero product principle, one term has to be 0. So we have x minus 2 is 0, or x minus 5 is 0. Plus 2 on both sides, and then plus 5 on both sides here. So x is equal to 2, and x is equal to 5. And we write the solution as 2 and 5 in the curly bracket. Okay, that was that. Solve equation by factoring. Note that we try to simplify the problem whenever possible. Both of these are even, so divide by 2 both sides. Okay, x squared plus 3x minus 5. We do the same thing. First, find the two numbers times together equal to first times the last. And now they add up together equal to the middle number of 3. Right, so let's see how that works. Product of negative 5 could be 1 times negative 5 or negative 1 times 5, and that's all we have, right? 2 times 2.5. We're not going to choose 2.5. We only choose whole numbers or integers. Choose integers only. And so we cannot find the two numbers. That means we cannot factor. And that is that. The equation still has solution, but we just cannot solve it by factoring. So here we say cannot factor. So factoring is nice and all, but in some scenarios like this, we cannot factor. So there must be a different way we can solve for an equation that works every time. And this is the method that works every time here. And we solve quadratic equation by completing square. So we complete in square because when the square is complete, we have a square. And very important in this class, you see this many times. This is a square. If we have a square equal to a number, for example, if I ask you x squared is equal to 9, then what do you say? Okay, say, okay, 3 times 3 is equal to 9, so that's good. But then I say, how about negative 3? 3 squared is equal to 9, but negative 3 squared, negative 3 times negative 3 is also 9. So if we have x squared equal to 9, there should be two solutions, x equal to plus 3 or x equal to minus 3. To be just right, plus or minus 3, like that. Let's see how that works. Okay, we keep that in back pocket. We say if we have a square equal to a number that is greater than equal to 0, then we have positive or negative. Remember, I'm just going to write x squared equal to a, then x equal to plus or minus square root of a. Okay, let's go with that. And a has to be greater than equal to 0. Okay, so we have a square equal to something. Now, how do we get the square? Let's work the problem backward. What if we have a square of like x plus b? Okay, so a square here means multiply by itself. Now multiply it out. X times x, x times b, b times x, b times b. And that is x squared plus bx plus bx plus b squared. And bx here are the same. Make that 2 bx plus b squared. Okay, so that's that. What's so special about this? We have x squared. Well, that's not really special. The part that is 2b here, if we take half of it, that's just a plus b, and if we square it, that is b squared. So the relation of the second term and the third term is that you take half of the middle coefficient, and when you square it, you get the third coefficient. Okay, so that's what makes it special. What also help that plus b is plus b. So we say x squared plus 2x plus b squared is equal to, we just put an x here and make a square. So that's how we do the complete square. Okay, there's another way to visualize this, but first let's go with that. Okay, x squared plus ax. Now the question is, find the number added to this, added to that, and make it a square. So what do we need to add, and what the square equal to? Okay, so let me write this down again. X squared plus ax. We're going to need to add something to make it a complete square. And to that something, first we're going to take half of this, half of the middle coefficient. That is the plus 4. And then we will square it. 4 times 4 is 16. So we're going to add 16. Once we add 16, we will have what? A square. And that's where we have this number, the half. Now we have x in it. Okay, so that is complete square. That's nice and all, but it could be even better. Now let's try visualize this. Let's say if I have a rectangle, the side 2 and 3, what would be the area? They'll say, well, that's easy. Length times width. So the area will be 2 times 3. Very simple, right? Now, for this, let's say, if I try to visualize x squared, can I say, okay, x squared is just a square of x times x, right? X times x is x squared. The area will be x squared. Now, the ax is a times x. Well, that's easy, right? Ax. I'm just gonna write this. This is still x. Let's say x is that, and this is 8. So that is ax. That's way, right? That rectangle. Let's split that in two. So that case we have what? 4x and 4x. 4 and 4. So x times 4 and x times 4, or 4x and 4x. So we split into 2. And so the ax here become 4x and 4x, right? Ax become 4x and 4x. Split the ax into 2 rectangles and then stack. This is x sine x times 4 and sine x times 4, right? Ax, 4x and 4x. X times 4, x times 4. And now to complete the square, we need to write that part. So what, then I ask you, what is this area? And you say, oh, okay, this is 4 and this is 4. So 4 by 4, that makes 16. So that's why we found the number 16. Okay. And finally, when we write like that, we say this will be x plus 4 and x plus 4 on the side. So that whole area is going to be x plus 4 and x plus 4. So x plus 4 square. Right. So complete the square, add 16 and make it a square of x plus 4 square. Okay. Right. Just like that. Now let's try again. X squared minus 7x, and we're going to need to add something. Always add something, because when we square, it's always going to be positive. So, okay, what is half of that? Say half of that is, half of 7 is 3.5. How about 7 over 2? Okay, 7 over 2, probably better. Okay, let's do the rectangle here. But that's probably easier to visualize. So it is easier to visualize here. So if x by x, okay, that is x squared, and the negative 7x, cut that in half, and we stack one square, this one rectangle this side, and one rectangle that side. And then of course, because of the negative 7x, we break in half. Each of them will be negative 3.5. 3.5. You can write that as a fraction or decimal, but let's for now. That negative 7 split into 2, negative 3.5. And of course, you see the area here will be negative 3.5x. Negative 3.5x. That's the area. Those together give us negative 7x. And what we make it complete square, this side 3.5 times 3.5. So it is 3.5 square. Alright, 49 over 4. We can use fraction, but 12.25 if you want to. So we're gonna need to add 12.25 and that end up being a big square of x minus 3.5 square. Yeah, that big square. They will say, okay, some math professor might not like fraction. I might not like decimal that use fraction, but that's fine. The principle is still the same thing here. The middle term, break that in half, stack it like this, and then we need to complete a square by adding something to it. Okay. Now, so that. Now, for this completed square, remember completed square we only need two terms. The last term will be determined based on the second term. So when we see the problem like this, the first one just subtract 5 on both sides. We need two terms only. So we end up with what? X squared plus 4x equal to -5. Okay. Now instead of find the third number, add to it and make a complete square, we can just find a number that we add on both sides. So I will find something to add here to make it a complete square, and if I add on this side, I have to add on that side. Okay, so x squared plus 4x. We do the same thing like previously, but this time I'm going to add the same thing on both sides. Now what do we add? Well, use same thing like breaking the 4x. So x squared, okay, that is the little square here, sine x by x. 4x is 2x and 2x. So break that down into 2. X by 2 and x by 2. So we have this area is 2x, this area is 2x, and this is x squared. And to complete this, it's going to be 2 by 2 or 2 by 2. 4. 2 squared. 4. So if you're going to add 4 on this side, you're going to add 4 on the other side. Okay. And the left hand side is x plus 2 squared. So x plus 2 squared. And the right hand side we have -5 plus 4. That is -1. Okay. Save that. Now you remember the principle we have earlier. A square equal to a number. So that we're going to be plus or minus square root. Now that will be what we do here. Even though the -1 is not positive, but that's fine. To get rid of the square, it's going to be, to get rid of that square, it's going to be plus or minus square root. So just write something very important. Plus or minus square root undo under a square. To get rid of the square, that plus or minus. And what is square root of -1? Well, beginning of the lesson, that's what we have is I. That's how we define it. The square root of -1 equal to I. So we have plus or minus I. And -2 on both sides. We have x equal to -2 plus or minus I. Yeah, you can write the answer like that, or you can write as -2 plus I, or -2 I. for that, solving equation by completed square. Now this completed square, again we only need two terms, so minus 10 on both sides. That gives us x squared minus 7x equal to 0. We need to find something to add on both sides. So negative 10, right? Yeah, minus 10 on both sides, sorry. Need to add something on both sides. And we already did that. That will be 12.5, 12.25. We're going to add that on both sides. And now that we have x minus 3.5. We do like we did earlier. The left hand side turn to x minus 3.5 square, and that gives us 2.25. Yeah, 12.25, 12.25 minus 10. That's what we have. And to undo the square, that will be plus or minus. Now we can just get rid of the square. Uh, 2.25 square root of 2.25. That 3 over 2 or 1.5. And we have plus or minus 1.5. And to solve for x, we're going to plus 3.5 on both sides. So if x equal to, we can say it 1.5 plus 3.5, so that is 5. And then a negative 1.5 plus 3.5, well, that is 2. So the solution is 2 and 5. As you see, we done this problem earlier using factoring method, and we have 2 and 5. So yeah, completed square also get 2 and 5. So using completed square method, we can solve pretty much any equation, even when it is complex, imaginary here. But this is a little more complicated. So another way, and what I will usually use will be quadratic formula. And we're going to use this. This method will work for all the numbers. But I want to do that in class because that's the common method that we use going forward. So I'm not going to use the whole class time here. Unless we work something today, and we continue that in class on Monday. Hopefully the school will open again. All right. So we stop here and then pick it up on Monday. Thank you for being here. Let me take this. And so have a nice day. See you on Monday.